Hello and welcome to this episode of Conscious Design. I'm your host, Ian Peterman, and author of the Conscious Design book. And today I'm excited to have Andrew Polanyi. He's the executive director at Ocean Aid, where they detect underwater objects to create a cleaner and safer ocean. Welcome to the show.
Thanks so much for having me, Ian. It's my pleasure.
Yeah, so for everyone who doesn't know or who likes to hear the story, let's talk about the origin story. How did this idea come about? Start there.
It's been quite the journey. I guess I'll go back a few years to where I grew up in Toronto, just in the city of Toronto. Always wanted to be an entrepreneur. I actually started my first company when I was 16 years old. I sold juice at local farmers markets. It was called Juice Junkies. So started with a summer job, but kind of got the entrepreneur itch. And also when I was growing up in Toronto, I would fly out to Vancouver Island for 2 weeks to go, ever since I was 5 years old, actually, to go fishing with my grandfather here, all the way up island in Port McNeill for 2 weeks each summer. We went salmon fishing, halibut fishing. I learned so much from the ocean, from him, from being on the water, but also fell in love with the ocean, seeing the abundance of life it has. And that's kind of why I ended up moving out here to Vancouver Island. I'm currently located in Victoria, British Columbia, to study software engineering at the University of Victoria. And I started a company with my co-founder, Archit, during university called CipherSoft Inc. And we developed AI integrations, web applications, and really just met once per day for 1 hour to learn and work on software. So I developed a few apps, and when I was pitching during my final year, I was pitching one of these apps at a University of Victoria Planet event in front of judges. And I didn't end up winning that competition, but one of the judges asked to meet with me after, and he was part of the Coast, which is an organization here in Victoria that helps companies get into the ocean sector. And he came up with this opportunity, said that Ocean Startup Project has this community challenge open right now, and that he suggested that me and my co-founder Archit come up with a solution and join this challenge. And we kind of just jumped on that opportunity. And we started with the idea of mapping underwater objects, specifically plastics, with Sonar and AI. So from researching that, we ended up joining this competition, and we did over 150 customer interviews, talking with fisheries, talking with non-for-profit organizations. And from that customer discovery, we found that there's a huge problem with ghost fishing gear. And this is something that we'll talk about a bit, Ian, but I guess I could hit the audience with some cold ocean facts to start us off here. I have 14 million tons of plastics enter our oceans each year. And of this plastic, it's not just floating on the surface like everyone thinks. It's estimated that more than 90% of it actually is in the water column or on the sea floor. And of that plastic, 70% of it is ghost fishing gear. And this is discarded, lost, or abandoned nets, traps, and ropes from the fishing industry that kills 5 to 30% of harvestable fish. And that's coming off a stat from the Government of Canada, which I welcome all the viewers to go to the Government of Canada's Ghost Gear page to learn more about ghost gear. But that's just a staggering number of fish that are being lost to this ghost fishing gear. And I guess I could tell a little bit of a story of how that happens. If you imagine a trap on the ocean floor that's lost its buoy, there's no way to recover it. It continues to fish as new crabs, for example, enter the trap. They get stuck. They fight for their lives in this gladiator-like coliseum, and eventually they die, and their remains attract more crabs to enter that trap. And that process is endless until the trap breaks down, taking hundreds of years sometimes, or it's retrieved. And that's really what stuck with me. And we wanted to make it more efficient to locate and retrieve that gear. So that's where OceanAid was founded upon. It was founded with taking sonar data and automatically detecting traps, nets, and ropes to make it more efficient for fisheries, First Nations, and ocean restoration companies to essentially retrieve that gear. So we created priority areas where there's the most gear with the best conditions of retrieval, so you can go out and do as much efficient retrieval as possible. So yeah, I guess that's a little bit of the background for you, Ian. There's a bit more story I could tell a bit, but yeah.
It's something that, we talk about plastic, right? A lot as people now. It's a common topic, right? That's a huge amount, right? As you said, most people think about, the bottles and like Trash Island in the Pacific and things like that, which is, easy to see, right? You can take a photo of it and go, hey, look, I saw it. It's here. It's a problem. But what you're saying is there's a huge percentage of ocean plastic that is way below where you would normally see it, bottom of the ocean. Most people don't go there.
Totally. And most people don't see it. That's the big problem, Ian. It's out of sight, out of mind. I've also often, one of our organizations that we work with told me this example. If we could drain the ocean just for a day, just to show just how much stuff is down there, it would blow people's minds and actually start bringing people into this problem and helping solve it. But the problem is we can't do that. And it's out of sight, out of mind, and the fact that they don't know the problem, how bad it is, and how much of an impact it's causing. And I didn't even know how bad it was. Even when I did the research, I heard the facts until I did a pilot project with a First Nation and actually saw in the data how many traps are out there. We detected 1,100 traps in less than a 15-kilometer radius. They were just stranded everywhere. In a single image of sonar image, we could see hundreds of these traps. So if you imagine the effect of having those continuously fish, but it's not just traps, right? It's ropes that hang up whales, and it's nets that have the same effect of catching fish, attracting more fish into those nets, and creating, I guess, wreaking havoc on the ocean ecosystem. So it's really unfortunate because it's a huge problem, and there's a lot of work that needs to be done, and the current methods are not efficient enough so that they're costly, and it's also reliant on government grants. That's the other thing. There's no real business model behind it other than receiving grants from the government to do this work. Even though all these traps are labeled with the fisheries identification so that we know where it's coming from, there's no repercussions of losing your gear out there in the ocean. So I think something needs to be changed in order to make this into an actual business, because we're losing millions of dollars each year of harvestable fish, driving food prices up, but also ruining the sustainability of our ocean. And I'll hit you with another cold ocean fact. In BC, in 2020, it was almost $1 billion, the BC seafood and aquaculture industry. If you take 5 to 30% of harvestable fish being caught each year, that's 50 to almost $300 million of product that's being lost each year. And this fish would essentially be able to reproduce. So over time, we're losing a lot more than that. So there is like a big market in recovering ghost gear in that sense, but there's no direct case that makes it viable for businesses to get involved. So that's why when I heard that the Ghost Gear Fund of Canada was not being renewed in 2024, all this money that was being put into this problem has been cut off. So all the organizations who have been building infrastructure and building a standard operating procedure to do this work has now been cut off, and it's a huge problem. So we're actually been looking into the States more and working with US companies as they have more funding right now, but we're also looking into other applications of this technology. And I'd love to get into a bit about our technology and how it not only helps with ghost fishing gear, but many other applications that might have a bigger market to them right now, but also create an impact in the ocean.
Well, it's perfect. That was actually going to be my next segue is we have the problem, and then you guys have developed a technology to collect the data, right? So let's dive into what is your technology? How does it work? What is it doing as a case?
Yeah, totally. So I guess we start with sonar data. And sonar data, for the audience that might not have seen it before, it's actually echoes of sound hitting the bottom of the ocean or going through the water column, hitting the bottom and bouncing up. And dependent on the time and I guess how strong that signal comes back, that makes a picture of the bottom and the water column, and it's essentially an image made out of sound, or as they call an echogram. And we take this sonar data, whether it's a side scan sonar or a multi-beam sonar. There's many different types. They all have different pros and cons. The main one we work with is a side scan sonar, which essentially gives a good swath of the bottom, as it not only goes straight down, but it also goes to either side and almost creates a paintbrush stroke of the bottom. So we don't make or manufacture any of the sonars. There's a lot of leading companies that are developing that cutting edge technology and hardware. What we do is we provide the software to pair with this sonar to provide accurate and timely detections and identify objects. So the system that we've generated is called an automatic target recognition system, or ATR. And our ATR system pairs with side scan and multi-beam sonars to automatically detect nets, traps, and ropes, so ghost fishing gear, but also derelict vessels and planes, so finding wrecks for search and recovery, human bodies for search and rescue. And we're actually scaling this technology into many other applications, such as detecting fish for fisheries, for sustainable fishing. We're looking into also detecting whales and marine mammals so that these fisheries can detect fish, but also be able to reduce the impact on the whales, reduce the collisions. So having like an early detection for whales so that they can bring up their gear before reaching them.
Is it hard to detect whales now? You would think that they're pretty big. You should be able to detect them.
Yeah, you're right, Ian. Yeah, so like bigger objects are definitely, they come back with a bigger signal. That's why our most accurate model right now is actually the derelict vessels and planes, because they're hard, so they reverberate a big sound, but also they're bigger. Same with whales. We haven't done a lot of research into this, but we've seen sonar images with whales in them, and they essentially have a larger reverberation. Same with bigger fish like sturgeon in the Fraser River. There's been work done to identify sturgeon, to count fish, and that's definitely an application for this as well. Where OceanAid really provides value is in that real-time detection, so that you don't have to take your data and go home and spend hours looking through it, or hiring an expert to spend hours to look through it, which costs a lot of money. You can just get that first pass right away to find objects as soon as possible. And this is, I guess, a big problem because there's a real big lag usually in going out surveying, and then surveying meaning going to scan with a sonar, and then having to bring it back home and spend almost the same amount of time going through the data and hoping to locate something with your eyes. So what we've built is in the ATR system, which is built off tens of thousands of these instances trained or put through an AI to basically train it to detect for these objects, which makes it a lot more accurate, but also a lot quicker. So, yeah.
So does that mean that you can use sonar a bit more like a video then,
Yeah.
and you can really just as you're trolling up and down, you are actively detecting and marking.
Yeah, totally. So a lot of work has been done in this ATR space, but it's all been in the post mission. So detecting, going home and sending it through software to detect for things that takes a while. And where we really want to bring value is to be able to detect on the boat, like you were mentioning, Ian, with that video detection, see it as it comes up, but also map it as it comes up. So you can go return to it. You see a point of interest, and you can actually go back around and do a second scan of that to make sure and double check what you're seeing.
So you can add like geolocation data and things like that. You can aggregate other data on top of it easier.
Yeah, totally. You can get all sorts of data from that, from the AI. You can get how large the object is, but also, most importantly, the precise location so that you can pinpoint that trap or that net and go retrieve it as soon as possible, because the ocean moves a lot. There's tides, there's storms that come through, and that trap or that net that you detected a week ago or 2 weeks ago, depending on how long it takes you to go process that data, might not be there when you return to that location. So that's where that real time comes in, especially with the search and rescue and search and recovery. Having that real time technology would help you find a boat that's sunk as soon as possible, so the oil and gas doesn't have as big of effect on the ocean ecosystem and stuff like that. But yeah, so it seems like there's tons of applications. We're really focused on that impact related thing, and also educating people about the problem of ghost fishing gear. And that's really why I'm here, to hopefully get a few of the viewers to understand just how massive this problem is globally, not just in Canada, but in Europe, in Asia, in the States. It's everywhere. And I wish, as I mentioned, we could drain the ocean and take some photos and show people. But at OceanAid, we're trying to make those invisible objects visible so they can essentially be better managed. And because the truth of the matter is, you can't manage what you can't see. And I guess that's the fact.
Hey, it's Ian here. So glad you're enjoying this episode of Conscious Design. If you want the full scoop on conscious design, what it is, how we do it, how you can do it, then check out our book. We wrote it so creative entrepreneurs like you can code social and environmental responsibility right into your brand's DNA. You can download the first chapter for free. Link is in the description. Enjoy the rest of the episode. Don't forget to like, subscribe, and share.
Now, let's talk about ghost gear a little bit. So you're saying that, right, they have labels on them. So is there requirements? Like, is this, because when you say like ghost gear, it kind of sounds like shady practices and like illegal fishing. How much of it is like that, where it's intentional, we're going to go do this and if stuff breaks, we abandon it? And how much of it is just commercial? It's not an intentional abandonment. They're trying to do what they can, but it just happens to disconnect, and there's no repercussions, so they ignore it.
Yeah, that's a great question. And I think you hit it right on the nail that there are no repercussions right now. It is legal commercial and recreational fishing that are being lost in the ocean, and they can get lost in many ways. If, for example, a recreational fisher doesn't understand the tides quite well enough, or didn't check the tides, and they don't put enough rope on their trap, the buoy picks up the trap and takes it somewhere else with the current. As the high tide comes up, it'll just lift up the trap, and the current will take that somewhere else in the ocean, and they'll come back and they'll be like, oh, my trap's gone. Someone must have stolen it, or I don't know where it is, so I have no idea how to find it. Or a big storm comes up, for example, and this is a big problem on the East Coast, where they have sometimes even hurricanes come through, and these hurricanes will just take up all the gear, whatever's in the water, and break lines and scatter the traps pretty much everywhere. And people lose, I don't know exactly the statistics for recreational, but I think off the top of my head, it's almost up to like 10% of some fisheries, or 5% of traps and gear gets lost from the commercial fishing industry. So this is a big effect on just their numbers, and they just write it off, right? There's no law that states that they have to pay extra to go retrieve this or something. It's just part of the business, and it happens each year. So they do want to retrieve it from the fisheries I've talked about. There's just a big procedure to go. You have to report the gear as soon as possible to the DFO, Department of Fisheries. You report the location that you were fishing in and the gear lost, and hopefully someone is able to retrieve that and give it back to you before it becomes end of life gear. But right now, the process of applying to the DFO for a ghost gear permit to go out and retrieve this gear, it takes too long. And by the time you're out there, it's probably long gone, I'd say, like in a fully different area. So that's why we really need to drill down a standard operating procedure for locating missing gear and getting out on the water as soon as possible with a sonar in a boat, or even an AUV with a sonar on it, which is an autonomous vehicle where you can just deploy this from the shoreline or from a boat and go do the scanning very quickly, locate the gear, retrieve it, and give it back to the fisheries before it becomes end of life gear. So I hope that's the future behind it, and that there's a sustainable business plan around that idea of utilizing the best cutting edge technology to help solve this problem. And I hope that OceanAid's involved in that procedure.
Now, because you mentioned like things that seem a little bit more coastline, how does this, is deep sea fishing a huge thing? Is it more stuff near shore? Is it a mix? How does that, because I'd imagine you lose stuff everywhere pretty much.
You're right. You're definitely right. Like, it's everywhere. That's the thing. But the stuff that you can retrieve is usually within a few hundred meters of the shoreline, or in the depth of a few hundred meters. So that's the easiest stuff to retrieve. And there's enough of it that it'll take us a long time to just focus on that gear before going to the deep sea, because it's a challenge to retrieve as well, right? They use divers, they use grappling hooks and ROVs, but currently the cost of locating and retrieving this gear will be in the thousands of dollars per kind of trap, almost, in Canadian dollars. So
how much is a trap new? Like, is it super expensive equipment where like they spend 10 grand on it and it would be worth? Or is it like I spend $10?
Well, the buoys and everything, yeah, it's expensive. If you lose a long line of traps, each trap is almost $100 to $200. So it can add up very quickly, right? And
right, because you're talking about chained together, so you might have a bunch of traps on one line that goes missing.
Yeah, exactly. So that's essentially how the commercial crabbing or trapping industry works, is that they don't just have one trap on a buoy. They'll have two buoys on either end with a long line of traps. And if those buoys snap or something, then you lose the whole line and they get put somewhere else in the ocean. And I think it's worth talking a little bit about other technologies, not just to kind of prevent this problem from the source. And there's companies out there who are doing ropeless gear and essentially have systems where you can set a timer to, after you're planning to retrieve it, and if you go and you don't see your buoy, you can expect that timer to go off to send a backup buoy to the surface so that you can retrieve your gear. So I think to solve this problem, it's going to be a combination of new technology for fishing to prevent traps from entering the ghost gear realm, but also new technology to make it more efficient to locate and retrieve this gear that's already there. And yeah, I think we have a long way to go, but I think we can get there as well.
That's awesome. And for your technology, Rick, is it's software, it works with any existing sonar, like nobody needs to retrofit or anything. Is this something that, you mentioned like boats, but also autonomous vehicles? Is this something that you could put on the autonomous vehicle software to be able to instantly just notify people, oh, there's something here, 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 and here. Are you have any limits with that? Or is it just because your software, you can write along anything?
Yeah, that's a great question, Ian. So there's three main ways to integrate our ATR system. So the first one is through API, where you need internet access. You can either dump a large amount of data to our API, or you can continuously feed data. The second is application downloaded to your laptop, which you connect to the Sonar via Ethernet and get those detections. So we actually started on a fishing sonar, a high quality fishing sonar. When we ended up winning that competition through the Ocean Startup Project, we bought my grandfather's boat and fishing sonar to get out on the water, start collecting data, and essentially prove that this technology is viable. It actually works. So you connect your laptop with the application to that sonar to provide you that live detection on your laptop. And the third method is actually, we have these real-time Marlin series boxes, which we're prototyping right now. These are built off NVIDIA's CUDA system and have different levels of their newest AI chips. So we have Marlin Blue, which is in my hands right here, Marlin Black, and Marlin Commercial. And we're currently prototyping Marlin Blue and Black, which are trillions of operations per second. So this is our lowest model here. This has 40 trillions of operations per second.
Only 40.
Only 40. We call it TOPS. And Marlin Black actually has triple that, so 120. And then Marlin Commercial, we hope it's kind of customizable based off the needs of our customer, and different sonars have different amounts of data that come in. So if you have like a very high-end industrial multi-beam sonar, you're going to need bigger than Marlin Blue or Marlin Black to be able to have that split-second detection. So we're really excited for the potential of these real-time, I guess, hardware that's optimized for our software to be able to go on AUVs and be able to replace the laptop on board to provide that split-second detection. And yeah, so there's kind of those three ways to integrate. And I think kind of that's the future, being able to have AUVs and USVs, so unmanned surface vessels, to go out, do the surveying, and work together. So you can send out multiple of these AUVs, and they call that a drone. I forget the name of them, but having multiple doing the scanning at once, then having that automatic detection to essentially do that first pass of going through the data and getting all the detections out. So there's a lot less human work of going through all the data, and saves you money and time. So
that's cool. You have the hardware to be able to allow those autonomous type vehicles to be able to leverage the software too. That's awesome.
Totally. Yeah. And I guess the driving factor comes back to that time on the water with my grandfather, and the vision of still being able to go out with my grandchildren one day, and hopefully you can go out with yours and enjoy the ocean just like I did with my grandfather. And I think we need to work with the ocean as it's one of our greatest assets so that we can thrive as a civilization, because there's just so much still to learn about the ocean, and we can treat it so much better than what we're doing right now. So
I love how expandable your technology is, right? You're talking about ghost gear, but also search and rescue, and even be able to track, fish and whales and things like that. Like you said, it's one of those places, the ocean, like we enjoy it from the surface typically, or maybe a few feet down, but most of the time it's on the surface, and it's something that we don't see very much. And it's always spectacular if we see something. It's always attention grabbing. It's not seen very much, right? So I love the fact that you're able to illuminate and be able to find and track other things. Like you said, it is one of our greatest assets as a planet, having it. There's no us without it. It's vital for everything. So being able to really see it, I think very important to be able to actually take care of it. I think you made some really good points about that.
Totally. Yeah. Thanks, Ian. I guess that kind of brings me just to the future of ocean aid, maybe, and these other applications that I've touched briefly on, but maybe could talk a little bit more about where we see this going in the future. And essentially, we're a very small company right now, probably one of the smallest companies you've had on Conscious Design podcast so far. We're a 3-person team, myself, my co-founder, and we have 1 co-op student right now. But we're a pre-seed, fully bootstrapped B2B company, so business to business, where we provide value to those customers with sonar data or going out and doing scanning. But we look to be a global leader in marine monitoring technology, especially with this new wave of AI, and where AI algorithms are getting better and better. And it's really hard for companies to stay up to date with the latest AI technology. So having that small team that's focused specifically on the AI side and specifically with the sonar detection, I think we have a lot of value in providing those bigger companies with a lot of sonar data the ability to detect faster and more accurately across numerous applications. So not just with ghost fishing gear, search and rescue, derelict vessels and planes, but also, as I mentioned, on the fisheries side of things, detecting for fish and marine mammals, detecting for minerals and lots of things, resources down in the ocean, so that we can also help with the, transition to renewable energy. So with lithium for batteries and stuff like that, being able to automatically detect for resources is a big one. Also, infrastructure inspection for cables, pipelines, and ports, being able to detect for faults in this underwater infrastructure for scientific research. And I'm just listing applications at this point.
Oh, this is great. So much you can do with it.
Yeah. Aquaculture, where there's a huge boom in kelp products and seaweed and eel grass, and being able to monitor that and go out and automatically detect how much is grown and stuff like that. So a cool story is we were doing some scanning up in Port McNeill up island, and we were having some issues at the start detecting for ropes, and specifically kelp was coming up as ropes for us. So they looked similar down there, and we were getting a lot of detections for ropes, and it turned out just to be kelp, bull kelp. So what we had to do is go through all our data once again and label this kelp. So it's from that we found it's very possible to actually detect for bull kelp and honestly measure it, because you can see it from the bottom to the top and the depth.
You're able to measure that data too.
Yeah, so we didn't write the algorithm to do this, but I did some by hand just from Pythagorean theorem, which I learned, I think, 7th grade or something. But yeah, essentially you can measure that. Other than that, there's tons of applications on the defense side of things that we haven't really gotten into, whereas detecting for UXOs, which is unexploded ordnance, detecting for different defense applications. And really, there's just a lot of interest. We're trying to, in the coming weeks, narrow it down to which customer makes the biggest impact in our ocean economy and sustainability, aligns with our mission, but also pays us money so that we can work and continue. Yeah. So my hope is that the Ghost Gear Fund of Canada opens back up and we can start working with customers in Canada once again. But in the meantime, we're going to look for other markets like in the States, in Asia and stuff like that, but also consider many of these other applications that have a lot of interest in them. So
yeah, I would actually imagine a lot of some of the smaller island nations would have a lot of interest in this, or, even tourist areas that people want to know. Ecotourism, right? You want to boost that. Is your ocean floor clean? Like that could be a whole campaign for you of, well, It looks clean on the surface, but if it's not clean underneath, then is it really clean?
Yeah, but it's honestly not looking that clean on the surface either. Like shorelines, debris is coming more than ever. And this kind of brings me right into this cool project that we have proposed with Laqualums First Nation, which is up near Prince Rupert here on the island, not on the island, but northwestern BC. And we applied for this Clean Coast, Clean Waters Fund, which was available to essentially, and we haven't heard back yet, but we're very hopeful that we get it, because it's essentially to do a huge shoreline cleanup in their territory near Prince Rupert. But we're bringing new technology to it as well, because the current methods were to use a helicopter with a guy with binoculars to scour the shoreline and essentially create and locate where the most plastic is. And what we proposed to them was to develop the same ATR system, but with a drone and shoreline debris. So that's what we've been working on the past month. Actually, our co-op student has, and really excited because it gives the ability to just scan a shoreline with a drone and be able to detect and classify different plastics, get a whole load of data from it, but also give those hot spots where there's the most gear so you can go out and do efficient retrievals. So it's cool that we were able to, yeah.
I was gonna say, that makes me think of like river cities. Like I grew up around Portland, right? And there's two. There's Columbia and Willamette River. And it's they could both be cleaned up quite a bit. But again, the issue is, if you don't see it, if you clean the surface, then you can ignore it for another 6 to 12 months. We all know it's dirty because we know it's there, but nobody does anything because it's not in your face about it. But yeah, as shoreline, I would imagine river cleanup would probably be a huge area. It could use some help. That'd be also great. The city says, oh, we've cleaned the river all the way to the floor. That would be the first time for most of these rivers.
Yeah, exactly. So lots of work to be done. And I guess we're trying to bring the latest technology and AI classification so that it's more efficient to do this work. And I think there's a lot of work to do, but I'm very hopeful that we can do it and get it done so that, yeah, there's cleaner, healthier, and safer ocean ecosystems for us, but also plants and the animals that rely on them. So, yeah. I'm not sure how to end it here on my end. I don't have much else to say about that. More questions on your end?
No, this is great. It's amazing how much you've been able to do bootstrapping. So congrats on just getting to where you're at, where you have a viable technology, or you're working on the next iterations. I think you listed off a bunch of applications. There's so many things that this technology could be used for. And, being me, I would love to see it improve, right? Our oceans and rivers. It'd be great to see that reducing. If you can make it cheaper and then it becomes cost effective to actually do cleanup, and for a lot of places, that would be a huge piece, right? And if it's too expensive, no one's going to do it unless the government forces them, and that's going to take forever to get there. So reducing cost, I feel like your approach of going, hey, let's just make it more efficient, I think is a really good way to approach a problem that's expensive, right? Isn't just be more efficient and do it for less. I think that's a really efficient, it's an efficient way to approach it.
Totally. And hopefully one day for ghost gear, the government does make legislation to force retrieval to happen, because I think that would make a business out of this, make companies get into this industry of actually cleaning up the ocean and, yeah, have healthier oceans because of it. So right now, government grants are great, but if they don't get renewed like they did in 2024, I think it just ends the whole process right there. And all these workers who have spent years working on this industry and getting really efficient at going out and doing scanning and retrievals, that they have to find other jobs. So yeah, hopefully in the future there's more legislation and a bigger business opportunity. And I hope to educate people on the problem, to maybe start putting pressure on the government to renew the Ghost Gear Fund, but also tell them that this is a huge problem and we're aware of it. just because we can't see those underwater objects doesn't mean they're not there. And OceanAid, we're going to help try to bring those invisible objects, make them visible, and show Canada and the world just how big this problem is and what we can do to fix it. So
amazing. Well, to wrap up here, and links will be in the description for everyone, but where's the best place to find you guys, way to reach out, social website? What's the best way for anybody who's interested?
Our website's oceanaid.ca, so oceanaid.ca. Right now, we're working on some social medias. The one we post on the most is actually LinkedIn. So feel free to follow us on LinkedIn. It's just OceanAid, but also connect with me. I'd love to kind of talk with you if you want to learn more about Ghost Gear or the work that's being done or how you can help out. Feel free to connect with me on LinkedIn or send me an email at contact@oceanaid.ca. Always happy to have those conversations and also learn from you guys, because I know I've only been in this industry for around a year and a bit, and there's a ton for me to learn, and a lot of you viewers probably have a lot that could help me out in my journey to make the oceans more sustainable. So thank you so much for having me on board today, Ian. It's a great experience, my first podcast, but hopefully many more to come, and maybe in the coming years, I'll come back on with a lot more to talk about and some updates about Ghost Gear. So
that would be great. Hopefully some lower numbers, maybe we can hope for that.
Lower numbers, that would be amazing. Yeah, really appreciate it.
Fantastic. Thanks for being on the show.
And that wraps up another episode of the Conscious Design Podcast. If today's episode inspired you to bring your product idea to life and turn it into a sustainable 7-figure business, visit petermanfirm.com or click the link below. Your ideas have the power to change the world, and we're here to help make that happen. Thank you for joining us, and I'll see you on the next episode.